Chapter 10.5. Today's lesson is about Pascal's triangle and the binomial theorem. And the first thing you see is something talking about combinations. We're not really doing combinations with today's lesson. I think it'll be the next one. But the binomial theorem uses this information. So we're going to start with this just to make sure that you can do the math. And then we'll get going on what's really going on. Okay, so kind of quick introduction to just the notation. Combination. So the combination of n choose r. So n items, we're choosing r of them. This is the formula. N factorial divided by n minus r factorial times r factorial. Sometimes you might see it written like this. It's kind of looks like a fraction, but there's not a fraction bar. It's just the n over r in parentheses. If you see that, it also means combination. Honestly, I don't see it written that way much. It's almost always written like this that I've noticed, but it is just a different notation. So number one, just to make sure you can do this part. Find the combination of 8, choose 2. So that would simply be 8 factorial divided by 8 minus 2 factorial times 2 factorial. Now, just to be real clear, understand here the 6 factorial and 2 factorial. 6 plus 2 gives us the 8 that's on top. Okay, it's going to work out that way. N minus r factorial and then an r factorial is going to give us that n if we're adding them together. All right, now proceed using some of your previously learned factorial techniques. We're going to rewrite 8 factorial as 8 times 7 times 6 factorial. 6 factorial on bottom is going to stay. 2 factorial will be 2 times 1. Clean up this math. That cancels. That cancels, leaving a 4. So all we're really left with here is 4 times 7. We get an answer of 28. Next one. 10, choose 3. So 10 factorial over 10 minus 3 factorial, 3 factorial. 10 factorial over 7 factorial, 3 factorial. So 10 times 9 times 8 times 7 factorial. Divided by 7 factorial, but also 3 times 2 times 1. And again, just cleaning up this math. Those cancel. Those cancel, leaving a 3. Those cancel, leaving a 4. So I've got 3 times 4 is 12 times 10. So 120. Again, just making sure you can do the math. Last one, this one's kind of special case. 7, choose 0. 7 factorial, 7 minus 0 factorial, 0 factorial. So I get 7 factorial over 7 factorial, 0 factorial. What is 0 factorial? 1. So those cancel, and I'm left with 1 over 1, which is simply 1. So there's one way of not choosing any of the 7 items. All right, and last one, 8, choose 8. So 8 factorial over 8 minus 8 factorial, 8 factorial. So I've got 8 factorial over 0 factorial, 8 factorial. And notice it's basically the same exact thing, just the other way around. So there is one way of choosing all 8 of them. Chose the whole thing. So those last two are just little quick special cases, just indicating that that answer will be 1. Now again, this is not really today's lesson, but you're going to do a lot of that in a minute when we get to the binomial theorem. But first, we're going to start with review. Pascal's triangle. Okay, you have done Pascal's triangle several times. I know you did it in geometry. I know you did it arts. I don't know if you did in geometry or not. Actually, you did it junior high, I think. And I know you did it last year. But Pascal's triangle is a shortcut for the coefficients for binomials raised to powers. So we start with Pascal's triangle. Each term in each row is the sum of the stuff above it. So just go down once on the outside, but this 2 here is the sum of that 1 plus that 1. This 3 is the sum of the 1 and the 2, etc. So, and we sometimes refer to it as the 0th row, the 1st row, the 2nd row. So it kind of pay attention to how they are being compared, and the reason this is the 0th row is because it corresponds to x plus y to the 0th power. Basically, what you want to look at is the second number in Pascal's triangle. The second number will tell you what that coefficient is. And it looks like part of my parentheses got erased right there. So parentheses. All right. So number 2, expand x plus y to the 3rd power. And I'm going to try to go through this fairly quick because I think you know this already. X plus y to the 3rd power. Since the exponent here is a 3, we're going to look at where the second number in Pascal's triangle is a 3. And we do this because this is a binomial raised to an exponent. So my coefficients are going to be 1, 3, 3, 1. First term in the parentheses was an x. So I start with x to that exponent, which was x cubed. And now as I go across, decrease my exponents by 1 as I go, and I end over here with the last one. It's actually x to the power of 0. But anything to the power of 0 is the whole number 1, and I'm not going to bother writing that. Now start with the second term, y, and do the same thing in the reverse order. So it actually starts with y to the 0, which I'm not, well, I'll go ahead and put it here. But y to the 0, y to the 1st, y to the 2nd, y cubed. But that y to the 0, don't write y to the 0. I'm just going to erase that. And that is your answer. Notice my exponents here to start with, 3. Next one, 2 plus 1 is 3. Next one, exponents, 1 plus 2 is 3, and the last one's 3. Always going to add up to whatever it is we started with. Next, 2x minus 3 to the 4th power. Same idea, but there's a little bit more stuff involved. It's going to get a little bit more complicated. Now, because the exponent is 4, we're going to use the part of Pascal's triangle where the second number was a 4. So in this case, my coefficients are going to be 1, 4, 6, 4, 1. This time, my first term is a 2x. So the entire 2x gets the 4th power. The entire 2x gets cubed. 2x to the squared. 2x to the 1st. 2x to the 0, which I'm not going to write. And then now it's not a 3, but rather it's a negative 3 for my second term. Start with none of them, or to the 0th power. Negative 3 to the 1st. Don't write minus 3. Negative 3 being squared. Negative 3 being cubed. And I should end with a negative 3 to the 4th power. And that's basically the answer, but we're not done. We do need to go a little bit further, and we are going to have to just clean everything up. So as I get ready to clean it up, so now it's not just the 2 gets raised to the 4th power and the x gets raised to the 4th power. So we're going to have 16 x to the 4th there. Here the 2 and the x get cubed. So that gives me 8x cubed, negative 3 to the 1st power, still just a negative 3. The 2x all squared would give us 4x squared, negative 3 squared, positive 9. 2x to the 1st is just 2x. Negative 3 cubed, negative 27. And then a negative 3 to the 4th power is a positive 81. So whether or not you need a calculator for this depends on just how strong you are with your math. At this point, some of you might be reaching for a calculator. One positive, or positive, then a negative, it's going to make it all minus. 12 times 8 is 96, x cubed, plus 9 times 4 is 36, so this is actually 6 cubed. So 216 x squared minus 27 is a 3 cubed. 4 times 2 would be a 2 cubed, so that's also 6 cubed. So 216x, and then an 81. And that is our final answer. Don't know why I must have touched the board, but that looks like a decimal there. That's not supposed to be there. All right, and that's our final answer. Number 4, again, still, now you've got an x squared as part of one of your 2 terms for your binomial, but it's still just a binomial raised to a power. Same rules still apply. Since the exponent is 3, we're going to use the part of Pascal's triangle where the second number is a 3. So in other words, we're going to begin with the row that is 1, 3, 3, 1. Our first term in this case is an x squared. So the x squared gets cubed. The x squared squared, x squared to the 1st, and then x squared to the 0, which I'm not going to write. Second term is a 4. I start with 4 to the 0, which I don't write. Then 4 to the 1st, 4 to the 2nd, 4 to the 3rd. And again, clean it all up. Now, as we clean this up, I get x to the 6th now, plus 3 times 4 is 12, x squared squared, which would be x to the 4th, plus 4 squared is 16 times 3, be 48 x squared, plus a 4 cubed, which is 64. And that is our answer. But I do want to emphasize something. Don't know if you see the yellow or not. Okay, but because that was a 3, the sum of these exponents have to be 3. That was a 3. 2 plus 1 is 3. 1 plus 2 is 3, and that is 3. Pascal's triangle works with that. Now, because of our term here being an exponent, our final answers have different exponents. Don't worry about that. That whatever it cleans up to be is what it cleans up to be. But the first part, where you were actually applying Pascal's triangle, everything's got to match. And it does. All right. Now, that was Pascal's triangle, which again, I think is review. I hope it was review for you. What we are fixing to do is something that's a little different. I don't think you've done this before. And it looks pretty messy. This is the binomial theorem. It is also the expansion of a binomial raised to a power. Okay, so x plus y to the nth power equals the sum from r equals 0 to n. And notice what's right here? N factorial over n minus r factorial. That was that combination that we started with. And then first term x, that's your first term here. Second term y is the second term. Notice what the exponent of x is. Okay, the n minus r, that's this first part here. Exponent of the second one, r, that is that part right there. That is your formula. Important to note, it starts with r equals 0, which means the first term has r equals 0. The second term has r equals 1. So what would the 10th term have? The 10th term would be r equals 9. So r is always one less than whatever term it is we're talking about. Okay, that'll be more relevant in a few minutes whenever we get to the next example. All right, now, this is going to be a bit nasty. Bear with me as we look at this. Let's re-expand x plus y cubed using the binomial theorem. So the binomial theorem tells us, and I've already got it written up here for you. So x plus y cubed using the binomial theorem would be the sum from r equals 0 to 3 of 3 factorial, because that's not going to change, over 3 minus r factorial x to the, and again, this right here is what is the exponent to the x. This one here is the exponent to the y. But we're doing this summation. So as I'm doing this summation, first time through the loop, r is 0. So I'm going to try to write really small so I can make this fit, but I'll be surprised if I succeed. So I'm going to have 3 factorial over 3 minus 0 factorial, 0 factorial, x to the 3 minus 0, y to the 0. That's the first time through the loop when r is 0. Plus, now r is going to be 1. So now I get 3 factorial over 3 minus 1 factorial, 1 factorial. X to the 3 minus 1, y to the 1. Plus, now as I go through the loop, r is 2. 3 factorial over 3 minus 2 factorial, 2 factorial. X to the 3 minus 2, y to the power of 2. Plus, and now the last time through the loop, r is 3. 3 factorial over 3 minus 3 factorial, 3 factorial, x to the 3 minus 3, y to the 3. And now clean all this mess up. So as we start to clean this up, I'm going to have 3 factorial over 3 factorial, 0 factorial, x cubed y to the 0. 3 factorial, 2 factorial, 1 factorial, x squared y the first. All right, now cleaning this up. 3 factorial over 3 factorial, 0 factorial. That's what we started with on the up here, recognizing these problems over here. So all that's just going to be 1 x cubed. Now y to the 0, anything to the power of 0 is 1. And 1 times 1x cubed is still 1x cubed. So I'm not going to write the y to the 0 anymore. Plus 3 factorial. Think of it as, not that. Think of it as 3 times 2 factorial. Still over the 2 factorial. 1 factorial is just 1. X squared y. Plus. Now, hopefully you are noticing that this is basically the same exact thing. Now, the x's and y's and their exponents are different, though. And once again, 3 factorial, 0 factorial, 3 factorial is just 1. I'm not going to write the x to the 0, y cubed. Those cancel, those cancel. And what we are left with is simply x cubed plus 3x squared y plus 3xy squared plus y cubed, which is the exact answer we got right here when we did it in Pascal's triangle. Now, I'm not going to argue with you. I agree 100%. Pascal's triangle is a lot easier. Now, in your book, your homework, I think they might ask you to expand a few using the binomial theorem. Go ahead and do it because you need to practice with it. But I am not going to ask you to do an expansion. If you have to expand, I will allow you to do Pascal's triangle. But, question like this. Find the 6th term. So I don't want the full expansion. I just want a specific term. I want the 6th term of this binomial to the 8th power. That is when I would use part of the binomial theorem. Now, with that being said, I'm not doing the whole thing, so I would not be using the sum. So I wouldn't have that part. But I would have all of this for the one we're looking at. Now, you also have to know this part. So if I am looking for the 6th term, what is R? Well, as with all of these, R is 1 less than the term we're looking for. So if I'm looking for the 6th term, then that means R is 5. Now my exponent here, a plus 2b to the 8th power, tells me n is 8. So to find the 6th term, it's going to be 8 factorial over 8 minus 5 factorial, 5 factorial. What is the first term in the parentheses? It is an a raised to whatever that right there is. So it's going to be 8 minus 5. Second term is a 2b raised to whatever that is, to the 5th power. And that's basically the answer. Now, we're not going to leave it like that. We got to clean it up. But that is basically our answer to this problem. So cleaning it up, we got 8 factorial over 3 factorial, 5 factorial, a cubed times. Now, the 2 and the b are raised to the 5th power. We get this. 8 times 7 times 6 times 5 factorial. 5 factorials cancel. The 6 cancels with the 3 times 2. So I'm left with 8 times 7, which is 56. That part's easy enough. But then you got 56 times the 32. Probably need a calculator for that one. And we get 1792 a cubed b to the 5th. And that is our answer to this problem. So an example like that is where I would expect you to use the binomial theorem. If I want a specific term of your binomial raised to a power. So the entire expansion, Pascal's triangle. Specific term, binomial theorem. All right. And that was chapter 10.5.